Welcome to this Masterclass Explainer. I'm Sparky, your resident amp builder, and today we've got something absolutely brilliant lined up.
Hey everyone, I'm Wayne, and I am so ready to get this amp sorted out.
Spot on, mate. So today we are taking a standard, modern printed circuit board amplifier and utterly transforming the whole shebang. We're ripping out the guts and upgrading it to pure, boutique, hand-wired specs. It is a massive undertaking, but I promise you, the tonal rewards are just staggering. Now, Wayne, before we physically tear this chassis apart, I've got a question for you. What exactly happens to that glorious guitar tone when it's being choked out by thin, modern printed circuit boards?
Well, Sparky, it just gets completely sterile. Honestly, it's like looking through a really dirty screen. When we ditch that PCB, our ultimate goal is absolute signal purity. Like the quote says, we want an amplifier that acts as a window with no glass and no screen. We want every ounce of that rich, harmonic tonality from the guitar passing right through to the speaker with zero obstruction.
Brilliant! Right then, let's jump straight into Section 1, PCB to hand-wired conversion. This is the teardown phase, where we ruthlessly gut the chassis, ripping out the flimsy ribbon cables, the cheap pots, and the entire circuit board itself to clear the deck for our custom layout. You've really got to consider the physical and electrical differences at play here. Wayne, mate, what are we dealing with on the stock side?
Man, the stock board uses these super fragile ribbon cables, incredibly thin copper traces, and tiny quarter-watt components. They feel like they belong in a cheap radio, not a serious gigging amp.
Exactly, which is why we're stepping up to a heavy-duty, 1/8-inch thick G10 turret board. We're talking solid 18-gauge wire and incredibly robust 1-watt resistors throughout. It's virtually indestructible. So how do we actually build this bulletproof foundation? Well, it's a step-by-step process. First, we cut and sand the 1/8-inch G10 board so it fits the chassis perfectly. Second, we lay down our custom template and a metal drill jig right over the top to get the spacing exact. Third, we drop the metal turrets into the newly drilled holes and use a specialized drill press attachment to flare them out from the bottom. They're seated so securely they're never going anywhere. And finally, we install our heavy 18-gauge bus wire straight across those turrets. Now, looking at the newly built board, notice those thick red and black 18-gauge bus wires. Wayne, why on earth wouldn't we just leave those bare?
Because that is our power and ground rails, Sparky. By wrapping those rails in 600-volt Teflon shielding, we're keeping all that messy power supply noise totally isolated from our highly sensitive signal wires. It keeps the amp dead quiet, and to be honest, it keeps our hands safe from lethal voltages when we're poking around inside.
Safety and silence, mate. You can't beat it. Okay, moving right along to Section 2, upgrading to Mercury magnetics. Let's talk about the absolute muscle of this build, the iron.
Oh man, you literally cannot get dynamic, punchy tone without heavy iron. It is the heartbeat of the amp.
Quite right. That's why we're bidding those stock transformers and doing a massive upgrade to Mercury magnetics components. Let's quickly break down the physics here. An amplifier is essentially just a modulated power supply, right? The guitar signal is merely modulating the current. Now, the stock iron has a higher flux density and much lower primary inductance.
Yeah, which basically means it kind of chokes up and sags when you push it hard.
Precisely. The Mercury magnetics iron uses custom oven-baked steel with superior permeability and lower flux density. This completely revolutionizes the amp's AC regulation, giving you a rock-solid foundation that simply does not sag out under heavy playing. Just look at the sheer physical size difference between these two units. The stock power transformer looks like an absolute toy next to the massive Mercury Magnetics FDR-PRI unit. Wayne, tell the folks what this sheer mass actually translates to for the player.
It's a massive tonal reservoir, Sparky. Because this beast is rated for 120 watts, which is way more than our 2.6 V6 tubes will ever draw. It delivers this incredibly tight, piano-like low end. You could actually swap in bigger 6L6 tubes safely with a transformer this huge.
And we didn't stop at the power transformer. We upgraded the choke, too. Wayne, when you're really digging into the strings, how does the note attack feel with that new choke?
It's got this amazing, smooth, responsive bounce right under your fingers. It doesn't fight you at all.
That right there is down to the superior Q factor of the Mercury choke. Q factor is the measure of quality in a resonant system. A high-quality choke inductor beautifully smooths out the current flow, giving you that incredibly tactile, immediate response. All right, moving into Section 3, phase, inverter, and cap stacking. we're leaving the power supply behind and transitioning over to the preamp and phase inverter to dive into some dense component theory and really fine-tune the EQ. Right, so before the signal ever hits the power tubes, it goes through the phase inverter. This is an absolutely critical circuit utilizing a 12AT7 tube that splits the audio signal into two 180-degree out-of-phase halves for Class AB push-pull operation. Essentially, one power tube amplifies the top half of the wave and the other amplifies the bottom. To make this sound utterly massive, we upgraded the coupling cap feeding this circuit from a 0.001 microfarad to a 0.002 microfarad. This lets so much more mid-range fullness and lower frequencies pass straight through. But we definitely didn't stop there. Wayne, let's talk about cap stacking. Had you ever messed with this technique before?
I have now, and it is wild. You're basically combining different types of capacitors together in parallel to dial in the exact EQ you want, right?
Bang on. Different capacitor materials emphasize totally different frequencies. By stacking a smooth-sounding 0.047 microfarad Mallory polyester cap with a bright, punchy 0.01 microfarad polypropylene cap, we create a perfectly balanced, custom-tailored EQ that you literally just can't buy off the shelf. If you check out the main board layout, you'll spot those yellow Mallory caps stacked directly on top of the white polypropylene caps. And man, let me tell you, when you combine that custom capacitor blend with the incredibly pure tone of those new old stock 1951 French military 6v6 tubes, you get an overdrive that is aggressive, but still crystal clear. Every single note in a complex chord just rings out perfectly. Now, Wayne, I wired up a rather special switch on the back panel for you. Tell me, how does that newly installed triode/pentode switch actually alter the feel of the amp?
It is literally like having two amps in one. In pentode mode, it's loud, it's proud, and it has that classic blackface punch. But the second I flip it to triode mode, the volume drops and the response gets significantly darker, smoother, and it breaks up way earlier.
Spot on. From an electronic standpoint, when you switch to triode mode, we are tying the screen grid directly to the plates of the power tubes. This completely changes the electron flow inside the glass, mimicking a much older, lower wattage tube design. It's a genuinely brilliant tool for the studio. Right, let's move to section 4, bias test point setup. This is our final major technical modification for the power section, and it's absolutely crucial for long-term maintenance. So I pose this critical question to you, Wayne. We all know power tubes drift, they wear out, and they inevitably need replacing. But how do we let you safely bias those fresh power tubes without exposing you to the lethal 400+ volts hiding inside an open chassis?
You install external bias test points. That way I can just hook up my own multimeter on the back panel without ever having to take the actual chassis out of the wooden cabinet.
Precisely. And here are the exact build requirements to make that happen. First, we wire pin 8, which is the cathode, of the power tubes to a pair of red external terminals. Second, we install a highly accurate 1 ohm 1% resistor across from those red terminals to a central black terminal. Third, we ground that black terminal directly to a power transformer mounting bolt. We make sure it's snug enough to fit near the rectifier socket, entirely avoiding the slanted back panel of the cabinet. Looking at the internal wiring, you'll see those light blue wires attaching directly to pin 8 of the high-quality white ceramic power tube sockets. Wayne, the real genius here, is that 1 ohm 1% resistor. Thanks to Ohm's law, it flawlessly converts the current draw of the tube into a direct millivolt reading right on your standard digital meter. 1 millivolt equals exactly 1 milliamp of current. Which brings us to our magic number, 26. Wayne, to bias this amp perfectly, all you have to do is plug your meter into those jacks and adjust the CTS 10K bias pot from beneath the chassis with a simple screwdriver. You literally just turn it until your external voltmeter reads exactly 26 millivolts.
And just like that, I know for a fact I'm running exactly 26 milliamps of idle current per tube. It is completely safe, and it keeps the amp humming right at that optimal 70% plate dissipation sweet spot.
Spot on, mate. And with that final calibration, we arrive at section 5, the final hand-wired amplifier. We have taken a mass-produced printed circuit board amp and executed a complete tonal and structural transformation. Let's quickly summarize the final rebuilt specs. We've got a bomb-proof 1/8-inch G10 turret board, massive Mercury Magnetics FDR pry iron, a custom cap-stacked phase inverter, heavy-duty 1K 5-watt screen resistors to protect the tubes from failure, and external bias test points for super easy maintenance. Wayne, tell everyone about the final result on the gig. Sparky, it is literally night and day. The low E string plinks like a grand piano. It's got this lush, three-dimensional swirl that completely fills the room. And honestly, the most important part, that rigorous hand-wired conversion means it has massive reliability. I can push it hard every single night and it never, ever breaks a sweat. And that is exactly how you do it properly, folks. If you want to dive deeper into the schematics, the specific parts we used, or hear some absolutely killer sound clips of this machine in action, you absolutely have to check out the full detailed write-up.
You can find all of that, plus my actual gig reports and stage setups, by heading over to waynereno.com.
Thanks for joining us for this explainer. But before we go, I want to leave you with this final thought. Does a modern gigging player truly need the vintage purity and rigorous maintenance of a hand-wired circuit? Or is the sheer convenience of modern printed circuit boards actually worth the tonal sacrifice? Think about it. Keep those soldering irons hot, and we'll see you on the next build.